Find the area of the largest rectangle that can be inscribed in a right triangle with legs 3 centimeters and 4 centimeters if two sides of the rectangle lie along the legs. So what I'm going to do is I'm going to put this rectangle in the XY plane in a way that makes life easy for us. So I'm going to put this right triangle in the first quadrant so that the right angle is at the origin, and then the leg that's 3 units long is along the x-axis and 4 units is along the y-axis. The reason I'm doing this is because we're going to have our rectangle inside of it, and the area of the rectangle is going to be base times height, which is x times y, if that opposite corner is at the point x comma y. Right? This width is x and the height is y, so this point is x comma y. So the area of this rectangle is going to be x times y. But here's the thing. We know that we have to get rid of x or y so that we can have a function of only one variable. But because the point x comma y is on this line, if we can figure out the equation for this line, that will give us a relationship between x and y that we can use to eliminate one of the variables. So if we look at this, we notice that it has a y-intercept of 4. So we know we can put this in y equals mx plus b form, slope-intercept form. If we know the slope and the y-intercept, we do know the y-intercept. The y-intercept is 4, so that's good. We just need to figure out the slope. Now, that's not difficult at all. The slope is negative because it's going down as it goes to the right, and the rise is -4, and the run is 3, so that's going to be -4/3. And we can use this to plug in for y so that we can write area just as a function of x. So area is x times y, but y is -4/3 x plus 4. And now we have an equation for the area that's only based off of x. We can also multiply that out because we know we're going to have to differentiate, and it's easier to do it term by term. So it's going to be -4/3 x squared plus 4x. And then let's differentiate with respect to x. The derivative of x squared is 2x. And if we multiply that by -4/3, that's going to be -8/3 x. And then plus the derivative of 4x is 4. We need to know when this is equal to 0 to get our critical number. We can add 8/3 x to both sides. And then to get x alone, we can multiply by 3/8 to get rid of that 8/3. 3/8 times 4 is going to be 12/8, and that is the same as 3/2. So this is going to be our critical number. So we'll want to know the area when x is 3/2. If we look at what x could be, the most it could be is 3, and the least it could be is 0. But in both of those circumstances, the area is going to be 0. Because if x is 3, then there's no room for there to be any height of this rectangle. And if x is 0, the height can be high, but there's no width. So both of those give an area of 0, right? The area when x is 3 is 0, and the area when x is 0 is 0. So this critical number has to be our maximum. So if we plug in 3/2 for the formula for area, that is -4/3 times 3/2 squared plus 4 times 3/2. So what is that going to give us? 3/2 squared is 9/4, and -4/3 times 9/4 is going to be -36/12. And then plus 4 times 3/2 is 12/2. Well, -36/12 is going to be -3. plus 6, and that equals 3. So that means the largest the area can be is going to be 3 square centimeters, or 3 centimeters squared. And that's our answer.